Looking at part B. So we're going to multiply by 1 plus 4i. So in the numerator, we have 2 plus 3i times 1 plus 4i. We are going to have to FOIL that. So 2 times 1, 2 times 4i, 3i times 1, and 3i times 4i will give us 12i squared. Now, when you multiply the conjugates together, 1 plus 4i, 1 minus 4i, what you will end up with is first times first, 1 times 1. If you did the outers, you would get positive 4i. If you do the inners, you get negative 4i. Those go away. So really, you just have first and last. Okay. So negative 4i times positive 4i is negative 16i squared. So look for I squareds and make those negative ones. So in the numerator, I have a 2 plus 8i plus 13i. So the i's added together give me 21i. And I have a 2 plus 12 times negative 1, which would be the same as 2 minus 12. So I get negative 10. In the denominator, I have 1 minus 16 times negative 1. So those are going to become positive. So I have 1 plus 16, or 17. Now, since there are no i's in the denominator, this is simplified. And 10 is not divisible by 17, and 21 is not divisible by 17, so we can't simplify any further than that. That would be your final answer. So how does this whole idea of imaginary numbers affect us when we are trying to do what we've been working on all chapters, solving quadratic equations? So we're going to look at an example. What are the solutions of 2x squared minus 3x plus 5 equal to 0? When you see an equation that has an x squared and an x, the first thing that I want you to do is move everything to the left-hand side and have 0 on the right. Okay. Second thing I want you to do is see if you can factor that. Now, I'm going to tell you right now we can't factor that. Even if it was possible to factor it, if you don't see that it's possible to factor it relatively quickly, you should just move on to the quadratic formula. So since it is not factorable, I'm going to identify A, B, and C. I am going to write down my quadratic formula. So the number in front of x squared is our A, so A is 2. Number in front of x is B, so B is negative 3. Number on its own is C, so C is 5. Quadratic formula. Plug in what we know. So the opposite of B. B is a negative 3, so the opposite of that will be positive 3. B squared would be negative 3 quantity squared minus 4 times A times C all over 2A, which is 2. Right? So we plug in our numbers for A, B, and C. And then we work on solving this. So look inside the square root to simplify. Negative 3 squared is what? 9. Negative 3 times negative 3 is 9. What's 4 times 2 times 3? 4 times 2 is 8. 4 times 2 is 8. Times 3 is 24. So we have 4 times 2 times 5 is 40. So we have 3 plus or minus the square root of, we said that negative 3 quantity squared is 9, and 4 times 2 times 5 is 40. 9 minus 40 is negative 31. 2 times 2 is 4. What you're going to do at this point is look and see, can we break down the square root of 31 at all? Okay, answer is no, we can't. But if we could, you would want to do that. Pull out anything that you can. Pull out any pairs. There aren't any. We're also going to take out the I. So I'm going to do 3 plus or minus I square roots of 31. So we put an I out front and change it to a positive over 4. And those are your solutions. Now, I have been saying that we can write it like that, or we can split it up and do 3/4 plus or minus I times the square root of 31 over 4. Either one of those is fine. And there's nothing more that we can do to simplify that.